Okay. So last session we discussed about operators, right? And now we'll go to our next topic, which is again a very important topic, which is conditions. Okay. Now, what conditions are like, so far we've been executing the program in sequential manner, right? We wrote 50 lines of code, 100 lines of code, and all those codes were executed in sequential fashion, like one by one. So, and not always that's the case, when we need to do, like, for example, if you have to assign grade, simple thing, right? Every student will get a grade, right? But their grade will depend upon the average, right? So, so you need to print a specific grade, okay, you assign a specific grade based on the average. So that's a condition situation. Okay, that means you cannot say grade A to everyone or grade E to everyone. Okay, you need to assign a certain case. Now, based on your input, let's say I want to know whether let's say you input a number. Okay, based on if that number is positive or negative, we need to perform certain action, right? So I need to know whether that number is positive or negative. Only then we can decide what action to follow. Not both actions will continue at the same time, right? If it is positive number, then you do the positive number stuff. If it is negative number, then you perform the negative number stuff, right? So it's not done, both will not be executed at the same time, right? So those are the situations when we need conditions. So it's like we're asking a question. Is this or this? Is it positive or negative? Okay. And of course, you can have multiple questions, right? You can have just one single question. Okay, if this, then do this, otherwise don't do this, anything, right? So, we don't have to mention anything for don't do it, correct? But there are situations where you might have two conditions where if positive do this, if negative do this. You can have multiple conditions. Okay, if more than 80% print grade A, if more than 70% print grade B, if more than 60% print grade C, right? So you have multiple conditions in that case. So it can be one condition, two conditions, or multiple conditions, right? Any number of conditions. You can't restrict on the number of conditions. So how do we implement such conditions in Python? Okay, that's the topic for today. Now um, let's say, we have average. Okay, directly we'll take average. And now say if average is more than 90, you give certain thing, like let's say you give president award, let's say. Okay. So if average greater than equal to 90, print you win president's award. Okay. And I'll say print thank you. Now if you look at this thing, right? Now let's explain what I've written. So average is 90, and what we want to do is we want to award, or we want to send a message to all those who got award equal to or more than 90. And we want to send a message to them saying that you win president award, right? And that's it. Okay, if it is not, if they don't get it, that's okay. We don't have to do anything for them. So in this case, I'm using this if clause. If is the beginning of condition, if condition, right? So conditions are implemented in almost all programming language, right? We have seen this in Excel also. We have seen this in decode kind of operation in SQL also, right? Same thing we are doing here. If is the beginning of condition, and if is followed by your comparison operator. Ultimately, if needs either true or false. If needs a Boolean value. If needs a Boolean value. Okay. So if is if, that means if true, then you go inside if. Okay. And if is false, then you don't go inside this. Now in this case, 90, is it greater than or equal to 90? Yes, it is true. So it will go inside if. Now to indicate inside if, you have to give some space here. Okay. Now if I do, like for example, if you take this print is not inside if. So this print is part of your main execution. So this will be called anyway. But this print is inside if. Why? We gave a space. So it's like this print is reporting to this if. Okay, now if I put it here, then this print is outside if. For Python, even one space is enough. Even if you give one space, Python knows that, okay, this print is inside this if. Okay, and if the condition is true only, it will go inside. If the, it's like a gatekeeper, right? So if the condition is true, only then you go inside this. If it is not, then you don't go inside it. Okay, if it is not, then you don't go inside it. If condition is false, you don't go inside it. If condition is true, only then you go inside it. Okay, so that's called condition, single condition. Now you have a choice to give number of spaces, right? For Python, as I said, even one space is enough, but you can have multiple spaces, not a problem. Okay, thing is, the number of spaces that you give, of course, your program will have more than one line. So number of spaces that you give should be same for every line that you type within this if condition. Okay, so if I have to write one more, like 90 plus is 2 good score. Now, what happened is I am giving this second line also I want it to be part of if clause. So in this case, the spaces that you give should be same as this spaces. So you have choice only for first line, how many spaces to give. Okay, from second line onwards, you have no choice. You have to give same number of spaces. Okay, for second line onwards, you have no choice, but you have to give same number of spaces, right? So this is what we call as indentation. Okay, an indentation is mandatory in Python because of indentation, it knows whether it has to be part of certain block or part of your main block. That's why we have seen earlier that when when you want it to be part of main block, even one space here will create error, right? Okay. Generally, what we do, we give one tab space. Okay, because one space, we may not be able to see it properly. We might miss it. Okay, you may not know whether it's part of if or part of main. So one tab space is good. Okay, but default tab spaces are 4 spaces. But you can always change the settings. So one tab space is what is generally given, but there's no restriction. Python is happy with one space also. Okay, but as I said, for first statement, you have a choice to give the whatever spaces you want to give. For second line onwards, you have no option but to give the same number of spaces. Okay. Okay. So when I run it, P2, yes, P2. So you win present server and 90 plus is 2 good score, because these two statements we have under if. If I go and make it to 80, condition becomes false and you won't be able to get inside this. Make sense? So you won't be able to get inside this, and because of which what happens? Your if everything that you put inside if doesn't get executed, right? So this is situation where you are checking one condition, right? Okay, if condition is not met, then you're not doing anything. Okay, now let's look at when you have two conditions. Okay, now I want to do, okay, let's do it before this. I want to check, okay, if student has passed or not. Let's say passing mark is 40%, right? And I want to check if the student has passed the exam or not, right? So I'll check if AVG greater than equal to 40, you say print you have passed, right? and I need to have alternate condition here, alternate not text here. That means if it is 40, then you say it is passed. But if it is not, then you need to say failed, right? So print, sorry, you have failed, right? So this is example of two condition, okay? If and else. If will have condition, else will not have condition. If is checking whether it is true or not, right? So average more than 40, is it true or not? If it is true, you'll go inside this. And if it is not, then default. Else is like default. If it is not true, then execute else. Okay. You don't have to check conditions here because it's a default condition. If it is not true, then you just go and execute this. Right. So when you have this, so see, you have passed, and because it's more than 40, right? 80. So this condition became true, you have passed, right? Else, obviously, from if and else, only one will be executed. If else is, I mean, if has false, only then else will get executed. If is true, then obviously nothing else will be executed. Else will not get executed. And then it checks. Every if is a different block of code, right? Now I have written if else here and then another if here. So if indicates beginning of a block, we say if block, right? If else is also part of if block. So this is your first block of condition. This is becomes the second block of condition. So they are independent of each other. This is independent, this is independent. Okay, so if is like your starting point. Okay, so this if first if that we have written line number 5 is different than 11. They are not connected anyway. Okay. Now let's say we now will try to implement multiple conditions. Okay. So what we have seen so far is if you have only one condition, you'll use only if, correct? But if you have to handle two conditions, okay, if and in default condition, then use else, if else, correct? But if you have more than two conditions, that's when you use elif, or we call it as else if. Elif or else if. Else if is a situation where, you know, if is not true, but you have one more condition to check. So elif stands for else if, else, but then you have if, you have to check one more condition. So you see, else you are not checking condition, right? Else is like default one. In Excel, we only had if else. So if you have to check more condition, we were checking inside else. Again inside that else. But higher level programming languages like Python, C, C++, Java, they provide you capability to handle multiple else at the same time. In Excel, we couldn't do that, right? So that's why in else we wrote another if. But here you can write multiple uh, conditions. Okay, so let's do it here. Okay, so let's start with grade A. So if I say if AVG greater than equal to or 80, we say print you scored grade A, right? Elif AVG greater than equal to 70. Okay, you say grade B. Okay, then you go Elif. Okay, so if you have to handle 5 conditions, your first is if, last is else, in between all the 3 will be elif. Okay, last is else. Okay, so we'll say if less than 40, we'll give grade F or E, whatever it comes to. Okay, first is the first condition that you're checking. Then you have elif. Okay, and okay, let's do for ABG greater than equal to 60, and grade C. Let me copy it. 50, grade D, grade E, and if it is less than F of 40, so less than 40, you don't have to say, you have to say else directly, right? See, if it is more than 80, this will take care of. Okay, 70 to 80, okay. Now, if all these things are false, then this is a default condition. This will be executed anyway, okay. Use code grade F, right? Now see here, we have 80 here. So 80, this becomes true, isn't it? If 80 greater than or equal to 80 becomes true. So you have scored grade A will be called, okay, which is good. But now you see average more than 70. So 80 is also more than 70, isn't it? So this condition also becomes true, isn't it? So should we not get grade B also? Answer is no, okay. That's the beauty of a block. When you say block, okay, in block, only one part of the block will be called. If this becomes true, of course, in this case, this is true. This will be printed, and once it's like, it's like you have 8 doors, right? Or maybe what, four, right? 6 doors. No, one, two, three, four. Yeah, you have 6 conditions, right? So it's like you have 6 doors in front of you, and you're looking for your wallet, and you don't know which door of your wardrobe has your wallet, right? And you search first one, and you found your wallet. So will you look for the second door, third door? No, right? You will take it and you will walk out. You will not open the other door. If you don't find your purse here, then you go to second door. Or, if you don't find it here, you go to third. If you don't find it here, you go here. If you don't find it here, you go here. If you don't find it here, else is like, default. You open it. If you don't find, you take something or go, right? So if you found your stuff in the first door itself, then you will not even check the other conditions, right? That's what happens. If this is true, it will print score grade A, and none of the other statement will be called. So when I run it, you know, you see, you scored grade A, and then this if is called, and then this is if it's false, that's why it's not calling. If I make it 90, okay, now you can see all of these are called, right? Grade A, past, present, medal, 2 good score, thank you, right? So this is how conditions work in Python. I'll give you 10 seconds to just understand and let me know if you have any questions. No questions? Great. Okay, so this is a simple way of writing conditions. So what I'll do is I'll move them here. I think I've already shared these things. Okay, I don't know, this is not supposed to be. Okay, I'll save it. P2 is where we did, right? Okay, so now you come to P2. Okay, now so this is again sequential in the way that first this if is called, then if, then if. But within this block, you're controlling the flow, right? You're controlling. So sometimes it's called control statement also, right? You're controlling. Oh no, this will be called. These things will not be called. Now this thing should be called. Now this thing should not be called, right? So also sometimes we refer it as control flow, control statements. Okay, so 30, you go to else here, use code F, okay, else. Now you see, we can combine all of this together. Okay, how do we combine? We call them nested if inside if. Okay, now you have to start from somewhere. Okay, now this one, if you take this and this, okay, you have passed, right? Now you have passed will be printed for all these conditions, isn't it? 80, 70, 60, 50, 40. So one way is that you copy this and paste it in every block. If Elif, 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 Elif till here, right? And you delete this. Second condition is that since this is common, okay, we will print it only once and let's bring all of these here. Okay, now these are things which are above 40, isn't it? So I'm going to do Control X and move them here. Okay, and now for this block, this becomes the last default one, because see, starting only we are checking it is more than 40 or not. So if it is more than 40 only, you will enter these. If it is not more than 40, you will not enter into this. Correct? So if it is more than 40 only, you will enter. If it is not more than 40, you will not enter into this. So this becomes the default condition. Okay, you don't have to check here, because obviously it will be more than 40 only. So here you can say else, right? And now this one and 40, this is exact match. So I don't have to check for another if here. Directly I can put it here. You have failed, you scored grade F. Now, in terms of output, okay, you will not see any difference. Okay, in terms of output, you will not see any difference. Okay, now let's say average is 30 when you run it. Sorry, you have failed, you scored grade F. Now when we go and run our old code, okay, so here 40 we have to make, right? Now 30. Now when you run it, you see you score grade F. So grade F is first because we have written this first, and you have filled down. Okay, here it is, right? Reverse, right? So what we'll do, we just put this statement here, depending upon business case, right? If business wants you to print scored F grade first and then the result, you do it. So there's no difference now, right? So what did we do? We put if inside if. So this is main if, this is another door, and this is another door inside your door, right? So let's assume this is your bedroom door, and this is the door of your wardrobe, right? So if you enter into your bedroom only, you'll be able to access this. If you don't enter, if you enter somewhere else, you will not have access to those. So this is your first checkpoint. We call it as outer condition, outer if. Okay, and if this is true, only you're allowed to go inside. Otherwise, you don't go inside. Okay, so if average is 30 here, right? So this condition becomes false. So none of these will be executed. You directly come here. It makes the program more efficient. Less number of conditions, less number of checks. Okay, you makes the program faster. Okay, so okay, now if it is, let's say 50. So 50 is more than 40, so you get in. Right now, if you have to print, you have passed last, you cut and paste it here, right? This is also, see, everything here, like I, E, right? And now if I print here, let's say, something here, this is also part of this if only, right? Because you're beginning exactly under E. So E is under this if, and this is at same level of E. That means print and this elif belongs at same level. This does not belong inside else. So if I have to make it belong inside else, I have to give tab, right? Now this is inside else. Otherwise, this is outside else, right? So you have passed the second time will be printed irrespective of what you get here. Correct? Irrespective of what you get here, you have passed will be printed. Okay, so now coming back to our example, if average is more than 80, okay, this is after this 40. So now you see, if average is more than 40 only, it is possible to get average more than 80. If average is less than 40, in this case, can I put this here? Okay, can I put this here? No, I cannot put this here, because else means what? When average is less than 40. If average is less than 40, then only you're getting into else. How can you get average more than 80? If average is more than 40, only there is a chance of getting more than 80. Right? If it is less than 40, then definitely it's never going to become 80. So even if I put it like this line, Okay, it will never ever get called because else will be touched or else will be called only when your average is less than 40. Correct? So you delete it. And this is how you will use it. Okay. And here, as I told you that this is more than 40. So more than 40 becomes the default condition here. What I did, I merged these two together. Now, if I have to merge this 90, where should I put 90? You tell me. I have to put it somewhere here, right? So where should I put more than 90? Tell me. I'm checking for more than 90, right? So more than 90 has to be inside more than 40, correct? But inside this also, this is where you're checking for 80. This is more than 80. If you get more than 80, well, then there's a chance of you getting more than 90. I can't check it here. This is only between 70 and 80. So obviously 90 will not come here. 90 will be possible only if you get more than 80. So I'm putting one more if condition inside this if. So now you see that we have three levels of conditions: outer, inner, and innermost, right? So if more than 40, you come here. More than 80, you come inside. Now if it is more than 90, only you go inside this. So if it is more than 80, you're doing the regular stuff which needs to be done when it is more than 80. But after you perform more than 80, now you're checking if it is more than 90 or not. If it is more than 90, obviously if I make it 90 here, now you see all these three will be called, all these three conditions called. You have, okay, it's pointing to different file, P2. Okay, so you see, you have passed, you have scored A, and you win present medal, and 90 plus is too good. Right? Okay, and then this is the another one you have passed because this we have put it on same level as this. So you have passed again. Is it clear? I'm not getting any message, any reply. What happened? Vaspi says yes.
Yes, sir.
We are seven of us here. Hello.
Yes, sir.
Okay, I'm looking for others to also to respond. Hmm. Get up. Okay, so that makes us three. Still not 50%, but still okay. Okay, so of course, you into practice, okay, into practice, and more you practice, more you'll understand. So what we have done, we have built a conditions, right? So if I have to demonstrate here, so what we have done, we are checking if average is more than 40 or not, right? If it is, so you're coming in sequential fashion. Now you're checking, is it more than 40? So you'll have one side no and one side yes. Okay. If it is yes, then you're printing your past, right? Then again you're checking greater than 80. Okay. If it is yes, again you're checking greater than 90. And you perform certain condition. So that's how we are building the conditions. Okay, let's look at one more example. Okay, we'll look at one more example here. I told you, let's have a number equal to, let's say, 9. I want to check if the number is positive or not first. Okay, so I will say if num greater than 0, print number is positive. Okay, else print number is not positive. I'm not saying negative because number can be 0 also, right? If it is 0, it is neither positive nor negative. Correct. If it is um, like 0 value, it is neither positive nor negative, right? I'm checking if it is more than 0 or not. If more than 0, positive, else you say it's not positive, right? Makes sense? In this case, it is positive. Now let's break this also. So how do I break it into two conditions? Come on, speak something. Don't worry if it's wrong. Elif,
Can use else if, yeah.
num less than 0. Okay. If it is less than 0, then we say it is negative, correct? Number is negative. So now you see, if num is more than 0, it is positive. If num is less than 0, then it's negative. Only default condition becomes is when it is 0, right? More than 0, we have handled. Less than 0, we have handled. Equal to 0, we have not handled. How do you give equal to? Equal to equal to, double equal to. That we have not handled. So that becomes your default else condition. Number is
Not positive.
neither positive nor
Neither positive, not negative.
right. So yes. Okay. So if you say 9, it should give positive. If you make it minus 9, okay, it should be negative. Okay. And when you say 0, okay, you say neither
It's
positive
not,
nor
it's
negative.
neutral.
Right.
Yeah.
So
Yes.
see, this is called as checking all the conditions. When you do a testing, when you test the values, you have to check for all the conditions, right? Now, generally, you have a sequential flow, one single line of flow. There, one value you do, and you don't have to check. One single time if you do it, it's checked. If you have to check just one value. But in this case, you see there are three different branches. One, if it is this is one branch. This is second branch. This is third branch, right? Now, if I write two more conditions here, okay, if I write something, okay, if and some, something again, if I write, now how many branches we have? We got one, okay, this is one. When you follow here and this, we follow this and this, okay, so two branches. Then elif and if, this elif and this else, 2 plus 2, 4. This, I mean, you're coming from here, then this, and then the if, then this else, and then else. So you end up getting 6 branches, 6 different paths. So you have to do at least 6 different tests so that all those 6 possible, paths are executed. What we do is when we write such complex conditions, we end up creating hundreds of paths. And it's not possible to test all the 100 paths. So what we do, we test what's more common. So maybe we test only 50, 60, 70, 80. So when you test 80% of the 80 paths out of 100 paths which are possible or which are available, we say that code coverage is 80%. Code coverage means the code that we have covered for while testing, it is 80%. And 20% you have not tested because 20% is difficult to test and it will take a lot of time. You release the software, but in real situations all these kind of conditions will be executed, right? And then customer executes one of the conditions which you have not tested and that has error. So that's when customer will come up with a bug saying that we got a bug. Okay, you did not find it because you did not test it. Okay, it's not possible to test 100%. So, you tested only 80% and rest 20% you left it. Okay, and out of 20%, there is one bug which customer found it. Right, because customer, you'll have hundreds of customers, and obviously customers will test all the different situations, right? So this is how you get bugs from customer side. So this is called code coverage. This is called testing different flow, different code. Okay. So let's start building our example. Now, this is positive. Now, I want to check if number is odd or even only if it is positive. Okay. So if number is, first I need to check if number is positive or not. And I want to check if the number is positive only. I want to check if it is odd or even. So if it is only positive, then I have to do it here. I cannot do it here. Because if I do it here, separate, if I have to start, I have to check for positive, negative also again. Right? So since positive, negative is already done for us, then why do you have to repeat it again? No need to repeat it again. Directly you have to go here and see. So how to find if number is positive or not? We divide by number by 2 and check the remainder. If remainder is 0, that means it is perfectly divisible by 2. Perfectly divisible by 2 is your even number. Right? Perfectly divisible by 2 is your even number, isn't it? So if num. How do we get remainder? How do we get remainder?
Modulo.
Modulo.
Yes.
Right? So if num modulo 2 equal to 0, then you say print it's an even number. Right? And then you say else print it's an odd number. Okay, now you tell me how many paths are there. I told you what paths mean, right? All the possible flow. All the possible flow. Right? So here you tell me how many paths are there. So see, earlier example that I gave you was we had 3 conditions and then we had followed 2 conditions. So we ended up getting 6 paths, right? Now if you see here, okay, so one path will be if and this if is true. So 1, 2. Okay, so first will be this if and if, right? 1, then your if and this else, 2, then this is 3 and 4. So when you end up doing if elif, that is nested if, the number of paths has come down. Unlike when you put different if. Understand what I'm saying? Here, see, this will be true. This will be true only when this is true. Unlike if you had a if here, you have to check this if conditions anyway, irrespective of what you did earlier. So we ended up getting 6 different paths, right? So it's like, you have 3 conditions and then you have 2 conditions. So out of this only one will be true. So 1, and then here out of this only one will be true. So 1. So this and this 2. Okay, this and this 3, this and this 4, this and this 5, and this and this 6. Now what happened? Sorry. And this is inside. Now this and this is not possible, isn't it? This and this is not possible, isn't it? This and this is not positive. This and this is not positive. Correct? So you are reducing the number of touch points or number of paths. So now when you have less number of code coverage can be higher. Okay. And your program is more faster. Okay. You have to check less number of conditions, because if this is false, then obviously this will not get executed. Right. So you are saving time. Of course, if this is true, then it makes sense. There's no saving. So worst case, the time is same. In best case, time is saved here, right? So that's why, as much as possible, prefer to use nested if it is possible. Sometimes it's not possible, right? So then that's okay. Okay. So coming back to our example here. So I'm saying if number is divisible by 2, okay, so in this case, number is 0. So obviously, neither this nor this will be called, right? It's neither positive nor negative. If I make it minus 10, okay, so you end up getting negative, right? And if I say plus 10, so you get positive and even number. And when you say 9, so you get positive and odd number, right? So these are the 4 values that we tested. What? 0, minus 10, 10, and 9. These are the 4 values, and you'd have tested all the lines of code, right? That's why we said 4 paths. 4 different values will give us 4 different paths, and we have tested all the lines of code. Is there something which is not tested? No, all the lines we have tested. So it is 100% code coverage, right? 6 or 4 paths that you have here. Okay. Now let's say I have one more condition to add here. That is, if the number is divisible by 2, okay, or no, let's not do that. Let's see if the number is positive. If the number is positive, check if it is divisible by 2 and 3 both. If number is positive, okay, I can maybe write all these things. So first condition I'm saying, first condition is check for positive, negative, 0. Okay. Now I'm saying if positive, then check for odd or even. Now I'm saying if positive, check for if it's divisible by 2 and 3. So again, I'm checking for 2 and 3, right? Odd or even is again checking for 2, but again, I want to check. So, okay, so here it's saying that check if it is divisible by 2 or 3 or not. So what I'll do, I'll come here. Okay, now here the number is divisible by 2, but we don't know whether it's divisible by 3 or not. Correct? So I'll say if num modulo 3 equal to 0, then do something. Now when you're writing multiple conditions, you don't have 10 heads to think about all the 10 things at a time, right? So best way is first you form the condition and use pass. Pass is a way to tell that I don't have anything to add here. Because when you're writing if, there has to be something inside if block. Okay, and for now you don't write some, sometimes I write print just to say, just a dummy placeholder, or you say pass. Okay, we'll come back and add our logic. So I'm saying if number is divisible by 0, I mean modulo is 0, pass, else pass. And I'll just copy and paste it here too. Okay, because I have to check whether it's divisible by 2 or not 2 also. So this is if it is 2, and this is if it is not 2, right? Now I'll go and start building my logic. So I'll take one print and I'll say, okay, it's divisible by 2 and 3 both. Yes. Remainder here it is even. So even it means divisible by 2. And okay, num mod 3 is equal to 0. That means it's divisible by 3 as well. Now I will copy this and replace this path. Okay, so you can run it actually. Okay, now see, okay, 9 is not divisible by 2, so that's why it will go here, not here. So that's why we know this is not executed. But if I make it 6, okay, then you see it will be number is positive, it's even number, and it is divisible by 2 and 3. So this block is executed. And by putting pass, okay, it's not giving us error. That's the beauty. Okay, so you start building one condition at a time. You don't have to think of all the 4 conditions at the same time. Okay, you put pass, placeholder is there. Now you focus on only one portion, complete it, then you go to the next condition. So I'm going to say here it's divisible by 2 but not 3. It's not divisible by 3, right? So if I have to test it, this one, I will give something like 8. 8 is divisible by 2, but not by 3, right? By 2, but not by 3. Now, here, this is not divisible by 3, odd number, right? It is not divisible by 3. So here, it is divisible by 3 only, right? This is the logic I'm building here, right? So this is divisible by 3 only. Now, here, neither 2 nor 3. It's not divisible by 2 or 3. You understand what I did? Now you can test it. So positive number that is not divisible by 2 and 3 as well, 7. Positive, but not divisible, positive or, but it's not divisible by 2 or 3. Okay, 18 by both 2 and 3. Correct? Something by 3, but not by 2. Okay, what can be? 15, right? 15 is divisible by 3, but not by 2. Right? So we have seen all those examples, right? So this is how you end up building it. Now I can add one more condition. If it's now look at the condition based on that what I did. See, it does not say that it should be divisible by 2. If it says that it should be divisible by 2, then I would not have written this condition, because this is where it is divisible by 2. But it says that if it is positive, check if it is by 2 and 3 not. That means you have to check even if it is divisible by 2 or not. So that's why I put it at both the places. Okay. Now it's saying if it is divisible by 2 and 3, if it's divisible by both 2 and 3, then check for 5 also. So divisible by both 2 and 3. Okay. This is where it is divisible by both 2 and 3. Correct? This is where it is divisible by both 2 and 3. So now I have to check if it is divisible by 5 or not. Now you say print, yes, this is divisible by 5 also. Correct? So you ended up getting 4 level here, right? If. Okay, and now if I do 30 here, okay, 30 is divisible by both, or not both, all the 3, 2, 3, and 5. So it is by 2 and 3 both. Yes, it is divisible by 5 also. Right? So this is how you have to build it. Look at the problem statement and need to figure out where to go and add. Don't try to build 20, 30 lines of code at the same time. You build with just 2. You write 1 line, 2 line, 3 line. Then you say, okay, where should the 4th line fit in? Or 4th line should fit in here. 5th line should fit in here. Okay. So always start from simple program. Whatever be the complex business logic given to you, you cannot, don't even try to think of the complex logic at the same time. Break it. See, what line should I write? It could be middle path also, need not be from top, right? What it did, after writing, I went here and wrote this, isn't it? So it's okay. What is easy to implement, you have to do it. Okay. And then you start putting in. So the new line can go on top or in the middle. It doesn't have to be at the end. It doesn't have to be sequential. Okay. So this is how you can build a mini application using different conditions. Yes?
Yes, Swapnil.
Now let's do one more example before we end. Now I want to check, okay, check between 3 numbers, or arrange, let's say arrange the numbers in increasing order. That means if you give input as 5, 6, 3, it should result into 3 greater than equal to 5 greater than equal to 6. You know, you're arranging in 3, 5, 6. Or you can say 3, 5, 6, right? So whatever number you give, it should be rearranged to 3, 5, 6. Sorry. Now arranging 3 numbers at one go is difficult. So what we have to do is first we have to figure out 2 values. Okay, between 3 and 5 and 6, which is greater or which is smaller in this case, because we have to find the least value, which is greater. Okay, so between 5 and 6, 5 is less. Okay, so now we know that 5 is less than 6. Now you take the third value and check between 5 and 3, which is less. So between 5 and 3, 3 is less. So now it's simple, 3, 5, 6, because 5 and 6. So first I'm checking between 5 and 6, right? Because that's the first 2 number. Okay, if 5 less than, right? Not greater than, less than 6, yes. So 5 is less. So now I have to check for 3 and 5. Okay, 3, okay, or 5 less than 3. Okay, no, right? So when it is no, then you know that it is 3, 5, and 6. Correct? Because 5 is greater than, so less than 3, 6, and 3 is less than. So obviously 3 will be less than 6 also. But if it is no, I'm sorry, if it is yes, okay, if it is yes, then this is the smallest number, no doubt. The leftmost number is the smallest. But between these two, we don't know which is smaller. So again, you have to check a condition to see which is greater. So in this case, let's say you have 5, 8, and 6, let's say. 5, 8, and 6. 5 less than 8? Yes, it is less than 8. You come here. So 5 is less than 8. Now you compare 5 and 6. Is 5 less than 6? No. 5 is not less than 6. Right? Oh, sorry. 5 is less than 6, right? Let's make it 4. No. Correct. 6 is correct. Is 5 less than 6? Yes. So see, it is yes. So now we know that 5 is the smallest value. But between 8 and 6, we don't know which is smaller. So now you'll check for 8 and 6. Right? So 5 is smallest. Between 8 and 6, whichever is smaller will be second value. So 5, 6, 8, and this could be 5, 8, and 6. You know, if 8 is smaller, let's say. So you are ending up creating multiple conditions here. Okay, let's start implementing and see. So let's say I give a comma b comma c equal to, you can assign multiple values in one single line in Python, 3, 5, 6. So I'm checking if a less than b, simple. Okay, if means what? A is less than b. A is less than b. Correct? This is what it means. Now, if a is less than b, then I need to check for if a is less than c. Right? If a is also less than c, then a is smallest, but between a and b and c we don't know. Right? So I have to check for if b less than c. Understood? If a is less than b, then I'm checking if a is less than c. If a is also less than c, true, then I'm checking now b is less than c or not. And if this is true, then it is your, okay, it is f, it is smallest is a, okay, a less than equal to, the next one is, what is the next one?
B.
B. Okay, and now it is your C. Right? Now what I can do is, see, we have so many if, right? So we can have else for this, and I can say else pass. Okay, you have else here, pass. Okay, and then there's another else for this, right? And you say pass now. Okay, so this is true when A is less than B. This is A is, okay, less than C. Okay, and this is when B is less than C. Less than C. Now, when what is this else indicating? See, this else is inside this if and this if. That means A is less than B, A is less than C. It means A is less than B, okay, and A is less than C. Okay, that's what it means, right? But C is less than B here. B is less than C is false. That means C is less than B. Right? So now, if you look at these values, A is less than B, A is less than C. So obviously A is here. Okay. Now between B and C, okay, B and C, C is less. So you get C here and you get B here. With me, everyone? So we have built this situation. Now tell me, will this fall in this one? A is less than B, correct? A is 3 and B is less than B. So obviously here it falls. Now you check for AC. Is A less than C? Yes, A less than C. So it falls here. And for A less than C, we have handled it. So it should give us the result in the way we want. Okay. Equal to, right? So now you see 3 less than 5 less than 6. What happened?
The top line, in the seventh line
Here also, yeah. I copied and pasted, right? Yeah. So you get 3 less than 5 less than 6. Now, in this is case where C is greater. So C is smaller. So this has to be smaller. So I'll make it 4 here. Now, 3 less than 4 less than 5. This part is getting called. Right? Simple. You want me to build other cases or you will build it by yourself? Okay. So see, this else means what? A is less than B, correct? A is less than B. This is because it is inside this if. So A is less than B. But this is else here. That means C is greater. A is greater than C. That means C is less than A. So A is less than B and C is less than A. So straightforward, right? Which is smallest? A is less than B and C is less than A. So C is smallest. Right? Simple. And A and you get B. Right? See, 5 is less than 6 and 3 is less than 5. So obviously 3 is less than 6 also. You don't have to check for C and B here. Right? And same logic you have to do it for this because we have checked for BC, right? Now for AC and all this, you have to check here. Now, here it means B is less than A. What it means is B is less than A. So B will be before A. But should B be in first position or second position? Or A should be in the third position or second position? A cannot be first position and B cannot be last position in this half. So we have to decide the position of B and A. Should B be first or second, or C should be second or third? Correct? If B is first, then C again, if B is second, then A will be last only for sure. So let's check here. What? Between A and C? Okay, let's check between A and C. We can check for this also. So directly we'll copy and paste it here. Now, B is less than A. I'm checking is A less than C. Okay. Now, if A is less than C, that means what? B is less than
A and C.
B is less than A and A is less than C. That means straightforward, no else here. Correct? B is less than A. Yes or no? B is less than A
Yes.
and A is less than C. So obviously B is smallest.
B is the small.
B small.
And A comes here and C comes here. So in this case, you don't have to check for else. True? Now
Yes.
let's look at this case. Now here I'm saying, okay, B is less than A and C is less than A. So B is also less than A, C is also less than A. So we know that A is the last position. A has to be in third position. But between B and C, we don't know which should take first, which should sit second. Right? So we will write something like this. If, okay, let's not confuse it. Let's write it here. So I have to say A, and I have to check between B and C now, right? If B less than C, then pass, else pass. Now, in this case, A is greatest, so A will be third. Okay, B is less than C, so B and C. Right? Now you take and you paste it here. Here, A is last, right? But here, C is less than B. So C will be here and B will be here. Okay, so we have taken care of all the conditions. Okay, whatever value you give, you get an answer, correct answer. So 80, 60, and 40. 40 less than 60, less than 80. Right? So as I said, right, you have to build slowly, step by step. Don't try to boil the ocean. Okay, try to step and you will end up creating the final condition. You will be end up boiling the ocean, right? But don't try to do it at the same time. Make sense? We'll stop here today and please do practice, and we'll see you tomorrow. And tomorrow we'll talk about loops.